In this lesson, we're going to multiply and or divide rational expressions. Now, I'm going to go ahead and review just a little bit with arithmetic fractions. If you're asked to multiply, say, 2/3 times 9/20, it is easiest to multiply if you reduce before you multiply. And when you reduce, you look this direction, you look this direction, you look this direction, and finally this way. And because of the shape that is designed when you do that, I call it bow tie before you multiply. It's a little silly, but it helps us remember. Bow tie before you multiply. What that means is if you have 2/3 times 9/20, you look for common factors in the directions that would make up a bow tie. I see that 2 goes into itself once, 2 goes into 20 10 times, 3 goes into itself once, 3 goes into 9 3 times. I multiply the leftover factors. 1 times 3 is 3, 1 times 10 is 10, and I'm done. When you have a division problem, suppose you have 4/5 divided by 16/30. We don't actually do division with fractions. Instead, we keep the first fraction, we change the operation to its inverse, which is multiplication, and then we use the inverse of the second fraction. We divide. When we're supposed to divide, we multiply by the reciprocal. I call this one keep, change, flip. So when it's division, keep, change, flip, bow tie before you multiply. 4 goes into itself once, 4 goes into 16 4 times, 5 goes into itself once, 5 goes into 36 times. I still have, and this happens sometimes, 2 goes into 4 2 times, 2 goes into 6 3 times, and I end up with 3/2. Now what's going to be different about what we do is that our fractions are going to be made up of polynomials. So when it's time to do our reducing and we're looking for common factors, we have to have factored everything. So this is going to be an activity heavy in factoring. I'm going to need to factor all 4 positions if I can. So let's do our factoring on this problem we're supposed to multiply, the numerator. So I'm going to take these one step at a time. Down here, I'm going to do my factoring. All right, I'm going to take x squared plus 4x, the first numerator. There's a common factor of x, so that becomes x. X goes in there x times, x goes in there 4 times. The denominator of 2 I can't do anything with. The numerator of 15 I can't do anything with. The denominator of 3x plus 12, common factor of 3, so it's 3 parentheses. 3 goes in there x times, 3 goes in there 4 times. So now I'm going to come back up here. This is just my factoring work. So the numerator I will replace with x times x plus 4 over 2 times 15 over 3 parentheses x plus 4. So I replaced this numerator with its factored form. I replaced this denominator with its factored form. Now let's see what I can bow tie or divide out. X plus 4 goes into itself once and into itself once. I don't have anything here, but I do have something here. 3 goes into itself once. 3 goes into 15 5 times. You want to be very careful and see what you've got left. You've got an x, and a 5 and a 2 and a 1. I guess I could have circled that 1. X times 1 times 5 is 5x. 2 times 1 is 2. So I have reduced and then multiplied. All right, let's look at our next one. We're going to have a lot of factoring to do as we work through these problems. This is division, so I will keep, change, and flip. I'll go down in just 1 minute and do my factoring. Let's see, this denominator, 7x squared minus q. Although that looks rather complicated, I don't think there's anything I can do with it. So I'll just put it in parentheses. This numerator, if I have 21x squared minus 3q, I see there's a common factor of 3, and that's all I can do. So I factor out the 3, and that gives me 7x squared minus q. So I'll keep the first fraction. There was no factoring to be done. It's a little unusual looking, but nothing I can do. Times second fraction. The numerator has become 3 parentheses 7x squared minus q over 12. So it was division. I did a keep, a change, a flip. Then I factored the only thing I could factor, which was this numerator. Now looking for common factors. I have a binomial of 7x squared minus q and 7x squared minus q. 3 goes into itself once, and 3 goes into 12 4 times. And I think that's all I can divide out. What am I left with? I have 3 times 1 on top and 4 times 1 on bottom. I have 3/4. So remember, I'm writing my factoring work separate because it may take me a couple of steps sometimes to get something factored. All right, in this problem, this is multiplication. The numerator, 2x plus 5y. There's nothing I can do with that, so I'll put it in parentheses. Over, all right, I think I can factor this. I have x squared plus 10xy plus 25y squared. That's a perfect square. Nothing unusual, but so is that a perfect square. This may be a perfect square trinomial. So if you recognize that, you can take the square root of x squared, x, the square root there, 5y, sign from the middle, and we could check it. X squared is certainly x squared. 5y is squared, is 25y squared. The product is 5xy, double it for 10xy. Let's for a minute pretend that you didn't recognize it as a perfect square trinomial. And you said, no, I was just going to do trial and error. The last sign is positive. They're both positive. I have x times x. I'm going to have a y. What factors of 25 add up to be 10? And you say 5. And this is another way that you could have done the problem. I'll just go ahead and write it like that. I have x plus 5y times x plus 5y times the numerator. I have an x plus 5y, and it's over 2. All right, what do I see that's in common? I have an x plus 5y and an x plus 5y that divide out. Now, this is somewhat tempting, but it is a good opportunity for me to really mention to you that what you can divide out and what you can't. This 5y and this 5y are not factors. They are terms within factors. You cannot go into a set of parentheses that holds a factor and do any canceling or dividing. So 2x plus 5y cannot be touched on top. On bottom I have 2 times x plus 5y. The parentheses on top can be left off or they can be left on. That's my answer. You cannot divide these out. You cannot divide this out. 2 is a factor of the bottom, but it is not a factor of the whole top. It is a piece of a term on the top. So be very, very careful about that. All right, let's look at number 4. All right, this is division. So I will keep x squared minus 9 over 14x, change to multiplication, and flip 7xy over 3 minus x. Now, I will tell you 3 minus x, it really catches my eye, and I think that is not normally the way I see something written. That makes me think opposites might be involved. So let's see. Of all of these, the only one I can factor is this one. And I don't even think I need to go down here and factor it. That's the difference of 2 squares. And it factors into x plus 3 times x minus 3. 14x is left, 7xy up here, and 3 minus x cannot be factored, so I'll put it in parentheses. All right, what do I have? Well, 7 goes into itself once, 7 goes into 14 2 times. X divides out with x. I have x minus 3 and 3 minus x. Those are opposites. I can divide out opposites, and I have to remember that it leaves a -1 behind. All right, what does that leave me with? I have a -1. I'll just write these down. I'll probably reorganize. -1 times, I grabbed that monomial, I did it again, that monomial factor of y, and x plus 3. So I had this -1, I had this y, and I had this x plus 3. And it's over. All I have left down there is 2. What you would probably see is -y times x plus 3. You would not see the 1 over 2. So be aware, x plus 3 and 3 plus x are equal. They are the same, but x minus 3 and 3 minus x are opposites. So be aware of that. All right, number 5. Let's see if I have, okay, I have 5 and 6. I definitely need more room. I don't think I need that quite as large. All right, I have 4 different trinomials to factor. I think I'll do my factoring down here. I have x squared plus 18x plus 80. That gives me, last sign is positive. That means it's plus plus. I have x and x. I need factors of 80 that add up to be 18. How about 8 and 10? So that gives me x plus 8 times x plus 10. Let's look at the next one. I have x squared plus 6x minus 7. Last sign is negative, so I have one of each. I have an x and an x. 7 is a prime number, which means it can only be 1 and 7. I need the 7 to be positive. So the denominator there is x plus 7 times x minus 1. Next one, I have x squared plus 2x minus 3. That gives me x and x. I need a plus and a minus. I need the big one to be positive, so how about plus 3 and minus 1? I'm not going to say every little statement about the factoring. You could go back and review factoring if you need to, but I hope that's not the case. And finally, I have x squared plus 16x plus 64. I will tell you that this is a perfect square trinomial. I don't know that most students would recognize it. You would probably do it as trial and error. Both signs are pluses, x and x. I need factors of 64 that add up to be 16. It's 8 and 8. You could have it as x plus 8 quantity squared. Let's see where we have any common factors that we can bow tie. I see an x plus 8 and an x plus 8. I see an x minus 1 and an x minus 1. And I don't see anything else that is a common factor. I believe I'm left with x plus 10 times x plus 3 over x plus 7 times x plus 8. And that's it. We leave our answers in factored form. In other words, don't multiply them out. Leave them in factored form. Lots and lots of practice in factoring. All right. Final problem is a division problem. So let's do our factoring down here. All right, I have p squared plus pz plus bp plus bz. All right, I don't have a common factor all the way across, but there are 4 terms, so I'm going to do grouping. The first group, I see a common p. So if I factor out the p goes into p squared p times, and the next term z times. Bring down my plus sign. Common factor here is b. When I factor out the b, it will leave me with a p and a z. The common binomial is p plus z, so I'll factor that out, leaving p plus b. Oh, this is a division problem. So p squared plus pz plus pb plus bz over p minus b. Change, flip, p plus b over p plus z. Now I can do my factoring. The numerator, so I've done keep, change, flip. The numerator is right here. It is factored into p plus z times p plus b over the denominator is p minus b, and there's nothing I can do with that, so I'll put it in parentheses, times p plus b. Nothing I can do with that, so put it in parentheses, over, whoops, p plus z. Let's see what we have that we can divide out. I see a p plus z and a p plus z, and I think that's all. I have p plus b as a factor twice. It is more efficient to write it as p plus b squared. It would be okay to write it twice though, and it's over p minus b. It is tempting to think you could cancel those out, but you cannot. Never reach inside the parentheses. It is a p minus b and another p minus b, or just leave it alone. So that's how I would leave my answer. All right, multiplying and dividing. The multiplying and dividing part is easy once you get the factoring done. So if you need to, go back to your Unit 1 videos. I hope you don't need to, but the videos are there. You're going to have to use all of your skills for the whole rest of this unit. Good luck.